Suppose 5,000 is deposited into an account that offers a 2.25% annual interest rate compounded continuously. Now, if this problem were on the test, it would say using the formula, and I'd give you the formula. So you just have to know all the letters mean. And then I would continue on with how much will be on the account after 10 years. So if you remember the bread example that we did previously, the decaying bread, it was pretty much this type of problem, except then we did not know what logarithms were. So we could not do it without graphing and seeing where two lines intersected. Well, now that we know logarithms, we can find the exact answer. So in part A, how much is in the account after 10 years? Well, first off, let's build a function here. So we'd have P of t equals, what's our P naught here? How much are we starting with? 5,000. E is E, it's not a variable. To the K, our interest rate is 2.25%, so our K would be, very good. So remember, move that decimal 2 places to the left, 0.0225. And T is time in years, so we would just say 10. So to throw this in your calculator, you're looking for an e to the x button. Assuming you are not investing with Bernie Madoff, you should expect more than $5,000 in your account. If you don't know who Bernie Madoff is, read a newspaper. Read a newspaper. What do you get? $6,000. And how many cents? 61? Oh, that's nice. So if the question were how much interest was made, well, if you started with 5,000 and you ended with 62, 61, 61, then how much money did you earn? 12, 61, 61. So all you do is subtract. So just by letting it sit there for 10 years, that's how much money you made. Part B, how long would it take for the original deposit to double? By asking how long would it take, what variable are we solving for? T. So what's the setup going to be? Yep. So the amount of time T, since we want to double it, that means our P of T would be 10,000 is equal to, go on. Yep. Very good. So to solve for T, well, first off, what type of equation is this? Exponential variables in the exponent. So we need to isolate that exponential term by itself, and I mean truly isolate it. So that 5,000's got to go. How do we get rid of that 5,000? Divide. Now here's the thing. Most students, not most students, some students for whatever reason, they subtract 5,000 instead of divide by 5,000. Please, please, please be careful with that. Since this is a multiply, to undo multiplication, you divide. So if you divide both sides by 5,000, what do you get on the left? 2. And the E term is on the right. Here's the deal. It does not matter how much money you have in the account for it to double. So whether you're going for 5,000 to 10,000 or even $1 to $2, the answer is still the same. So this side is always double the P naught. So this will always end up as a 2. So if you're waiting for this to triple, this will always end up as a 3. So it's sort of depressing that it takes just as long for $1 to go to $2 as $5,000 to go to $10,000. But what it's based on is the interest rate, nothing else. So with that stated, we're trying to solve for T. It's an exponential equation where we cannot write them as the same base. So we should rewrite it as a A natural log. So the natural log of what? 2 equals, good. And then we just divide by t. So the exact answer would be natural log over 0.0225. Since this is a word problem, let's actually give a decimal approximation. So in your calculator, please find the natural log of 2 divided by 0.0225. Also note, when after you write your 2, end your parenthesis, otherwise that decimal will be inside of the log. We can't have that. $30.81. Did anyone else get that? So in 30.81, what's the unit? Years. Your original deposit will double.